This is 11.4b. Here are the answers to number 6. R equals 8, A equals 4, P equals 24 radical 3. That's the perimeter. The area is 48 radical 3 units squared. Okay, listen up if you want to hear the solution. Okay, those are the answers. This is the solution. All right, so from the center to the midpoint of the opposite side, that's the apothem. And so what we're given here is we are given that the apothem is, oh boy, what is it? We're told that the apothem is 4. So that's the information that we're given. Okay, this is problem 6. Yep. Okay, so this triangle here has a central angle of 120. The way we find the central angle is we take 360 divided by n, and that's 3. So this entire angle here is 120, and then this apothem bisects this central angle here. So this is 60. So I have a 60-30 triangle, which is similar to every other 60-30 triangle. And the ratio of the sides, 1, radical 3, 2. Remember, opposite the 30, smallest side length. Opposite the 60, middle side length. Opposite the 90, medium side length. Okay, so what I need to do is I have to find the radius, and I have to find this little piece right here, which I'm calling x. Okay, so I get my my scale factor, 4 to 1 equals r to 2 to find the radius of 8. Now I have the radius is 8. Good. And then to find this little piece, which I'm calling x here, again, the same scale factor, 4 to 1 is equal to x to 3. So I'm comparing the corresponding sides. Then I can multiply to get x is equal to 4 radical 3. The product of the means equals the product of the extremes. Now the perimeter, okay, so let me back up a little bit. If x is 4 radical 3, then this entire side length is 2x. So 4 radical 3 times 2 is 8 radical 3. The perimeter, I have 3 of those side lengths, so I need 3 times 8 radical 3. So the perimeter is 24 radical 3. Now I have enough information to use the formula. Area is equal to 1/2 the apothem. Okay, that's 4. And the perimeter, which I just figured, was 24 radical 3 for a grand total of 48 radical 3 units squared. My 2 and my 4, right? That 2 goes into the 4 twice, so 2 times 24, that's where the 48 comes from. All right, that's 6. 10, the answers to 10 are r equals 10, p equals 60, a equals, this is the area, 150 radical 3, the apothem is 5 radical 3. All right, so this time we're dealing with a hexagon, and let's see, what do they give us? They give us that the apothem is 5 radical 3. All right, so that's what I'm starting out with, is that the apothem is 5 radical 3. This is given. Okay, so figuring out the central angle, 360 divided by 6. That gives me a central angle of 60. The apothem bisects this central angle, so 60 cut in half is 30. So this is a 30, 60, 90 triangle, similar to every other 30, 60, 90 triangle on the planet, whose sides are in the ratio of 1, radical 3, 2. So I set up my comparison here, and what I need to find is I have to find this little distance here, x, and I also have to find the radius. Okay, so let's do this here. I know that the apothem is 5 radical 3, so I compare 5 radical 3 to radical 3, that's right here. 5 radical 3 to radical 3, that's my scale factor, equals x to 1. And again, the scale factor, 5 radical 3 over 3, is equal to r to 2, hypotenuse to hypotenuse. So solving this, I get radical 3. Well, actually, before I do that, I just cancel these radical 3's, and I get that x is 5. And then I get that canceling these radical 3's for this one to figure out what r is. 5 is equal to r over 2, so r is 10. So that's good to know. Once I have that x is 5, the side length is 10. I can figure out the perimeter. The perimeter for our 6 side lengths is equal to the perimeter, and so 6 times 10, my perimeter is 60. All right, and now I have enough information to figure out the area. The area is 1/2 the apothem times the perimeter. The apothem we know is 5 radical 3. The perimeter is 60. All right, so let's see. The 2 and the 60 cancel. This goes 30. 30 times 5 radical 3 is 150 radical 3 units squared. So that is the answer to number 10. 12, they give us, for 12 you know that the perimeter is 12 radical 3. All right, so what's given is the perimeter. So to figure out the side, I know that there's 6 sides, so 6s has to equal 12 radical 3. Dividing both sides by 6, I get that s is equal to 2 radical 3. So this side length is 2 radical 3. Remember from previous discussions that the apothem goes from the center to the midpoint of the opposite side. If this entire length is 2 radical 3, then this piece right here is half of that. Half of 2 radical 3 is just 1 radical 3. Now, the central angle here is 360 divided by 6 sides. You'll notice we keep doing the same things over and over again. Central angle is 60 for a hexagon, and so this is a 30, 60, 90 triangle. This is half of 60. That's where the 30 came from. All right, so to find the apothem, I noticed that my little triangle, 30, 60, 90, is similar to every other 30, 60, 90 triangle with sides in the ratio of 1, radical 3, 2. So to figure out the apothem, I'm going to look at my scale factor here, radical 3 to 1, and I'm going to compare apothem A to this guy, its corresponding side, radical 3. So product of the means, radical 3 times radical 3 equals product of the extremes, A, and so I get that A is 3. That's nice. I have the apothem now is 3. To find R, there's a couple ways you could do it. Do the scale factor, radical 3 over 1, and let's pretend here we don't know that R is 2 radical 3 is equal to R over 2. And so we have the product of the means, R, equals the product of the extremes, 2 radical 3. So I know that the radius is 2 radical 3, then I have enough information to find the area. All right, so the area 1/2 the apothem times the perimeter. The apothem is 3. I just substitute. The perimeter is what's given, 12 radical 3. And 2 goes into 12 6 times. 6 times 3 is 18 radical 3 units squared. That's 12. The B-level problem is 15, finding the area of a regular hexagon with perimeter of 72. So if the perimeter is 72, then I can figure out that the side length is 12. And this is a hexagon, so again we're dealing with 30, 60, 90. You should listen to the last problem, number 12, if you don't remember how to find the central angle of a regular hexagon. Okay, so the side length is 12, then this little piece is 6 because the apothem connects the center to the midpoint there. 30, 60, 90 triangle, similar to every other 30, 60, 90, the ratio of the sides, 1 radical 3, 2. The scale factor is 6 to 1. So to find the apothem, I'm just comparing corresponding sides, 6 to 1, A over radical 3, product of the means equals product of the extremes. Okay, to find the radius, same thing, scale factor, 6 to 1, radius to 2. 6 over 1, radius over 2, R equals 12. Now I have the information I need to find the area. 1/2 apothem times the perimeter. The apothem is 6 radical 3, and the perimeter was what was given up here, 72. And so the 2 and the 6 cancel, so I have 3 radical 3 times 72, which is 216 radical 3 units squared. Last problem here, number 17. Excuse me. This is very similar to one we did in class. I just named things a little differently. And I wouldn't even bother to try this, a regular decagon inscribed in a circle with radius 1. There's no way I'm going to try to draw that. So let's just pretend that I've drawn this nice little decagon, 10 sides, and that everything looks perfect, but there's no way I can do that. Okay, so all I need really is this part of the diagram. So from the center to the midpoint of the opposite side, that's the apothem. First thing I have to do is find the central angle. The measure of the central angle, AOB, is 360 divided by 10. Okay, so they really want that measure of angle AOX. So that's half of a central angle. So if I find a big central angle first, AOB, which is 360 over 10, remember to find a central angle is 360 divided by n. That's the formula. Okay, then I get a central angle of 36, but I only need half of it because the apothem bisects the central angle, so half of 36 is 18. So I know this angle here is 18. The next thing we need to do is they want us to find the sine of 18 and the cosine of 18. So let's look at this here. If 18 is the reference angle, relative to the reference angle, AX is the opposite side, the hypotenuse is 1, which is given, and OX is the adjacent side. So when I'm dealing with opposites and hypotenuses, I need to find AX. That's what I'm doing right here. I'm finding AX. And so to find AX, I'm using opposites and hypotenuses. That's sine of 18 equals AX over 1, and so AX is equal to 0.3090. I just looked that up in the table on page 311, or you could look it up on your calculator. To find the length of OX, OX, to find this is an adjacent side. So I'm trying to find the adjacent side. I know the hypotenuse. So the trig function that works with adjacents and hypotenuses is cosine. So I say that the cosine of 18 is OX over 1. Looking up cosine 18 in my table or on the calculator, 0.9511 is OX. Now, I need to find out the perimeter. So I know that AX, that's this distance here, okay, right here. How am I going to mark that? This distance here, that's 0.3090. So the side length of AB is twice that. So this represents the side length of AB. And, because it's a decagon, I have 10 of those. So I need to multiply that times 10 to get my perimeter. So I have 10 times the side length of AB. The way I get AB, that's 2 AXs. So that's going to be 6.18 when the smoke clears. That's the perimeter. Now, they also ask for the area of AOB. All right, AOB is this guy, AOB. All right, so it's the base. That's twice my AX. AX is 0.3090, so twice that. That's the base. So the area of the triangle is 1/2 the base. The base is 2 times this times the height. The height was OX. All right, the height is OX, and the base is AB. So you can see OX 0.9511, AB 2 of the AXs. All right. So when I actually do all that multiplication, I get 0.29389. Now, that's one way to find the area of this little guy. Then they want the area of the big guy. Okay, so I could just multiply 10 of these and get the area of the big polygon, or I could use my formula, 1/2 apothem times the perimeter. The apothem, remember, is OX. This is the apothem. And the perimeter we figured somewhere right here. Here's the perimeter, 6.18. And so multiplying 1/2 times OX, 0.9511, times the perimeter, 6.18, I get 2.9389. So as you would expect, this number is 10 times as large as this number. This area is 10 times as big as the area of one of the little triangles. All right, that's it.